All right, guys. I'm going to go over these quiz questions. I went ahead and pre-wrote some stuff here to reduce the length of the video. One thing I want to address here at the very beginning, there was a little bit of a typo on my part down here. I really wanted you to find g prime of -3, but I realized I typed that wrong at the bottom. So I'll accept this answer here. If you gave it to me, I'll accept either of the answers for g prime of 3 or g prime of -3 because of that confusion. So let's get into this here. Our setup here is a second fundamental theorem setup, and we are told that g of x equals the integral from 1 to x of f of x, and this is the graph of f. So essentially, this is the derivative of g. We're looking at the derivative of g. Okay, so it says find, I've color-coded these answers too. It says find g of -3. Well, g of -3 would be the integral from 1 to -3 of f of x. So g of 3 equals integral from 1 to -3, this is in blue, of f of t dt or f of x dx. And so I've got to find the integral from 1 to -3. Well, those limits are backwards, so I have to put a negative out in front, flip my limits. So now I'm trying to find the area under the curve from -3 to 1. So it's going to be negative, the area from -3 to +1. Well, if you look at this area up here, that's an area of +1. This is an area of -1. So those two areas actually cancel. This little square here is an area of -4. So altogether, that would be an area of -4. But since it's -4, we end up getting with 4 as our answer. In green, g prime of -3. Well, g prime of x equals f of x, right? Taking the derivative of the left-hand side, the derivative of an integral is just, in this case, f of x. So then what is g prime of -3 would just be f of -3. What is f of -3 in green? F of -3 is just +2. If you did g of +3, that right there would be -1. That's where the answer comes from. Finally, the second derivative. Well, if I were to take the second derivative of g, that would be the first derivative of x. And so the first derivative of f of x, or f prime of -3, what I've written over here in black, that just asks you what is the slope at x equals -3. And the slope at x equals -3 is just -2, right? I do rise over run, and that's how I find that slope. All right, I start to look at part B. Find the x-coordinates of any point of inflection of g. A point of inflection of g, and justify your answer. Well, points of inflection occur where concavity changes. So in other words, g double prime of x would have to change from positive to negative or vice versa. I'll write down that g prime of x equals f prime of x. That's me letting the AP grader know that I know what I'm doing. So where does f prime of x change? Well, f prime is the slope. So if we go back up here and we look at our graph, where does slope change from positive to negative? Well, if I investigate here it's negative slope and then a slope of 0. So that's not a change. Slope of 0, positive slope, not a change. Ooh, here it changes from positive to negative, so that's a point of inflection. Here it changes from negative to positive, so that's a point of inflection. So when I go down to justify my answer, I'll say there is a point of inflection. There is a point of inflection at x equals 5 because g double prime of x changes from positive to negative, and there is a point of inflection at x equals 6 because g double prime changes from negative to positive. That combined with what I wrote here is enough to justify my answer. Okay, guys, now I'm here on part C. This has asked me to find the absolute maximum of g. Okay, so the maximum of g. Well, maxes occur at the endpoints, so one possible place where that could occur is -5. Another possible max would be at +8. Those are the two endpoints. And also any critical numbers. Well, if we look, we have two critical numbers. We have one critical number here and another critical number here. we see those as potential max and mins. Well, remember what it means when a first derivative crosses from above the x-axis to below. If I go from above to below, that is a potential max. If I go from below to above, that is a potential min. Since they're asking for a maximum, I'm going to test the critical number where it crosses here only. And where it crosses there is at -2. So that's our x. Well, what's g of x? Well, to find g of x, we have to go through and we have to do that same thing that we did in part 1. G of -5 is going to equal the integral from 1 to -5 of f of x. Well, when I look at those limits, these limits are upside down and backwards. So I have to make that negative integral from -5 to 1. So what's the integral from -5 to 1? Well, I got to actually start calculating some of this area. So I calculate this area. This is a triangle with a base of 3 and a height of 6. 3 times 6 is 18, so that has an area of 9. I'm looking at this little trapezoid down here in this area. And so from that area, I get -1, 2, 3, 4. I get an area of -5. So if I'm trying to find that total area from -5 to 1, that would be -9 minus 5. So it's -4. Now if I want to find the area from 1 to -2, well, that's just this area right here. And that would be -5. So -5 would be +5. And if I'm trying to find the integral of g of 8, that's going to be the integral from 1 to 8 of my function. And the integral from 1 to 8, I'd have to calculate. Let's see, this is 1, 2, 3. This is -4. This is +1. And this would be +2. So that would be -4 plus 3. That's a total area of -1. So my maximum occurs at the point -2, 5, and the actual absolute max is 5. So the x value where that happens is at -2. The y value is actually 5. For part D, open intervals where g is increasing and concave down. So what I've written here in blue is me indicating to the grader what I know. I know that g prime of x is f of x and g double prime is f prime of x. I want to find where this is increasing. So that would mean that g prime of x would need to be greater than 0. In other words, f of x would be greater than 0. Well, where is f of x greater than 0? Any place the graph is above the x-axis. So that's from -5 to 2, from 4 to 6, and from 6 to 8. G double prime of x means that being negative or concave down would have to be less than 0. So that means that f prime of x, or the slope, would have to be less than 0. Well, where is the slope less than 0? The slope is less than 0 when it's negative. So I've got these intervals here where it's negative, and I have what I'm highlighting in blue where it's above the x-axis. So the intervals where we have both blue and red there is from -5 to -2 and from 5 to 6. And the way that you justify that is by saying g prime of x, what I wrote in green there, g prime of x is greater than 0, g double prime of x is less than 0 over these two intervals. And also what I put in the box here, I've indicated to the grader what I am looking at. Okay, guys, on to question number 2. Question number 2 is going to go a little bit faster than question number 1, which is a little bit more involved and by hand. This is mostly calculator active. I do not have a calculator video to go with this, but if you're not sure where I get the values, you can consult the other calculator videos, or you can contact me and we can meet on Zoom, or I can just kind of maybe make a video if there's a large number of you guys that need to see one. Okay, so we have this function here. We're going from 0 to 6, particles moving along the x-axis, velocity. We have a velocity function, and it says the particle when t equals 1 is x equals 5. That's interesting. A lot of times we get t equals 0. Here we have t equals 1, so that might come into play later. Let's see, what does it say? What is the total distance the particle moves from 0 to 6? That's easy, guys. That's just the integral from 0 to 6 of our function dt. If If you plug that function into V1, into Y1, if you plug V of t into Y1, cosine of t minus e to the negative t, it comes out pretty easily. You just type that in. You hit Math 9, make sure you use the absolute value, and you get 3.177. If it didn't ask us for units, and if we needed units, we could say feet. Okay, for part B. Over what time interval is the particle moving left? So I specifically state, even though it didn't say to justify my answer, I specifically state the particle is moving left when the velocity is less than 0. Okay, so if I already have the velocity plugged into y1, I just graph it and see where it's below the x-axis. Where it's below the x-axis is where velocity is negative, meaning it's moving to the left. So I did a little sketch of my graph there, and I had to use my zero function, but it crossed at 1.293 seconds and also at 4.721 seconds. So I used my zero function on my calculator, and that is the answer there. For part C says, at time equals 2, is the speed increasing or decreasing? If we're trying to see if the speed is increasing or decreasing, that is not just acceleration, that is comparison of velocity and acceleration. So in my calculator, I find v of 2, which you can just do y1 of 2 equals. And to get acceleration at 2 seconds, you have to do math 8. And so it would be d over dx of y1 when x equals 2. And that got me negative 0.774. Since both of these have the same sign, that means that the speed is increasing. Velocity and acceleration are working in the same direction. So to justify my answer, I say since velocity is less than 0 and acceleration is less than 0, it's justified because I put the numbers there. The particle's speed is increasing, not decreasing. Okay. We move on to question part D. Part D says, what is the position of the particle at x equals 3? We are used to saying, okay, x of 3 equals x of 0 plus the integral from 0 to 3 of v of t, right? That's what we're used to seeing. Well, here's the thing, though. They don't give me x of 0. They give me that x equals 5 when t equals 1. So instead of starting at 0, I'm going to start at 1, which means I have to start both here and at my position function. When I work that out, I get 3.982. Finally, for part E, a second particle B has position function. At what times do the particles travel at the same velocity? So I want to see when their velocities are equal. Well, I've been given the velocity of the first function. That's what I already have in my calculator. But the second function, they give me a position. So in order to get velocity from position, I have to take the derivative. The derivative of x squared minus 5x is 2x minus 5. So I have one of those functions in for y1. I put 2x minus 5 in for y2. And when I graph this on my calculator, we already knew that first function kind of did one of these. That second function is going to do one of those. And so you're just looking for the place where they intersect. And the place where the two velocities are the same in this case was 2.163 seconds. And what I can say then to justify my answer is kind of what I have in this box here. The velocity of the first particle equals the second velocity at that second, and I've actually justified what the velocity of particle B is right above it. So there's the answer to everything, guys. That is about the level that you're going to see on this exam. I hope that helps. Please do contact me before the AP exam if you're taking it so that I can help you if you are struggling with this. Have a good day, and I'll see you soon.